Hello my dear students, this is Akash SD and welcome to the ESD physics classes. So students, in this class we are going to learn about the derivation of the torque, that means when the dipole is placed in a uniform electric field, then how it will behave. After that we will see in a non-uniform electric field also, then we will see work done to rotate the dipole in a uniform electric field. Then after that we will learn a potential energy concept and where dipole will be in a stable equilibrium, unstable equilibrium, and we are going to see the reference position also. Okay, so all these things students, let's learn. Okay, so students, as I told you, first we are going to see force and torque acting on electric dipole in a uniform electric field, that means here UEF. Okay, so first one what we are going to see, resultant force experienced by the dipole. Okay, so first let's draw the dipole here. So we know very well the dipole means two equal and opposite charges separated by a small distance here, and this is called the center of the dipole. And you know very well students, this distance is called what? For derivation purpose, A. This distance is also A. Now what will happen, that this plus Q charge will experience force in the direction of the electric field, and here which kind of electric field is there? Uniform electric field, that means field lines will be straight and equidistant. Okay, so see here please, here this is the force on a plus Q charge, and here force on a minus Q charge. Okay, because positive charge will experience force in the direction of the electric field and negative charge will experience force in the opposite direction of the electric field. After that, if I draw this line, this is called the line of action of force F plus Q, and this one is the line of action of force F minus Q. That one we will use for the torque derivation. But first let's calculate the force. Okay, so see here please, this force vector F is given by force on plus Q charge plus force on minus Q charge. Okay, so Q and electric field is E, and due to minus Q charge also, minus Q and electric field is E, is it? So students, here the net force will come how much? 0, null vector. Okay, so we can see very well, hence resultant force experienced by dipole in uniform electric field how much? 0. Okay, so force is very clear. Now for the torque derivation, let's see, as equal and opposite forces due to plus Q and minus Q with a different line of action act on the dipole, hence resultant torque experienced by dipole is given by, so see here please students, this F plus Q will try to rotate the dipole in clockwise direction about point O. Similarly, this F minus Q also will try to rotate the dipole about point O in which direction? In the same clockwise direction. That's why we have taken the same is what? Plus. After that, students, you know very well what is the torque formula. Torque is given by force into perpendicular distance, F into R perpendicular. Okay, so see please here, this torque is equal to, due to plus Q charge, now we have written the force, and see here this distances we want here, this distance, this perpendicular distance we want. Okay, and this is M, and this perpendicular distance I have taken N. So can you see very well what is the perpendicular distance of line of action of F plus Q? Now, so here we can write here OM. Similarly, F minus Q, and students here please, perpendicular distance how much? ON, is it? Now, if you will use little bit geometry, now let's take here this angle is theta. And what is the angle theta? Theta is the angle between electric field and the dipole moment. Dipole moment in which direction? From minus Q to plus Q charge here. Okay, so you know this angle is theta, then what about this angle? This angle is also theta only. So when you will use little bit trigonometry, you can get OM will be how much? AN sin theta, and ON will be also how much? AN sin theta. That one will rise here. So F plus Q means magnitude Q into E A sin theta plus again QE A sin theta, because both they torque in which direction? Same direction. So when we will simplify this, it will come here 2AQ into E sin theta. And students, what is 2AQ? That is the dipole moment. Okay, so hence we can write here, no? Hence we can write, hence this torque is given by what? PE sin theta. Okay, P is the dipole moment, E is the electric field, and theta is the angle between the dipole moment and the electric field. Okay, After that, resultant torque experienced by dipole in vector form is given by, na? Because torque is a vector quantity, so which product we have to take? We have to take the cross product, na? Now after that, let's see students, last point, very very important, see please. In a uniform electric field, a dipole experiences no resultant force but a torque. Hence, under the couple, dipole will perform which motion? Pure rotational motion. Couple means very simple, net force is 0 but the torque is not 0, pure rotational motion, okay, and here the dipole is doing. Similarly students, if in case we talk about non-uniform electric field, so in non-uniform electric field what will happen, that the dipole will experience force also, net force, and the dipole will experience torque also, both the things it will experience, okay. So in this situation the dipole will do which motion? It will do the rolling motion, remember that please, okay. And here what I told, that both are experiencing but theta should not be 0 and 180 degree, remember that here, okay. Even here also, if the theta is 0 or 180, in that situation force will be 0, torque will be also 0. I am talking about some other angles and all that, okay. In all the situations we have to analyze the situation, instruments. Next one please, here please. Work done by external force in rotating a dipole in uniform electric field, okay. So see here please, here, as torque experienced by dipole is variable, therefore work done in rotating the dipole from theta 1 to theta 2 is given by. Why variable torque, students? Because torque formula P sin theta, and when the dipole will rotate, angle theta will also change, no? So here what will happen, the torque will become variable. So whenever the variables are involved, what we have to do, we have to use the integration, okay. So here please, here, work done by the external force is given by, what is the formula? Integration of tau into d theta, and from where to where we have to integrate? Theta 1 to theta 2, okay. Put the value of torque Pe sin theta into d theta. What are the things are constant? P and E is constant. After that, integration of the sin theta minus cos theta, okay, and here angle theta 1, theta 2, here also theta 1 and here also theta 2 is there, now take minus outside, so minus PE. Then what we have to do, first we have to put the upper limit, so cos theta 2, then lower limit cos theta 1. Hence, if we see here, work done by external force to rotate the dipole is given by PE cos theta 1 minus cos theta 2. This is the work done by the external force formula, okay. Now students, in next what we are going to learn, if in case during the rotation of the dipole, if the kinetic energy is constant, then what will happen? Work done by the external agent will stored in the dipole electric field system as which energy? Potential energy, and that is the concept. So here please, here it is defined as work done by external force in rotating the dipole from 90 degree to theta degree without changing the kinetic energy of it, okay. When the kinetic energy is constant, then only what will happen? Work done will store in the system as which energy? Potential energy, okay students. So let me write here, as we know that what I have told you, see please here, work done by the external force is equal to change in potential energy provided what is constant? Kinetic energy is constant, okay. So now let me write here, now I will just reverse it so that we can calculate the potential energy, okay. So what is the work done formula? Pe cos theta 1 minus cos theta 2, and here potential energy means final configuration minus initial configuration. Now we have written, now we have to see this one here, theta 1 90 degree, theta 2 how much? General angle here, okay. So we'll write here, see please here, here u theta minus u 90 is equal to, put please, Pe, and here cos theta minus cos 90. Now can you guess what is the value of the cos 90? Cos 90 will be 0, students. So we can write here, see please, u theta minus u 90 is equal to minus Pe cos theta here, okay. Very clear. Theta 1 we have to put 90, theta 1 we have to put 90, and theta 2 we have to put how much here? Theta, no? Just correct it here. So it will come how much here? Minus Pe cos theta, okay. Now what will happen that here, when the theta is 90 degree, that time we will consider the reference of the potential energy of the dipole, okay. So what we can write here, hence it will become here u theta is equal to minus Pe cos theta. And students, potential energy is the which quantity? Guess please. Scalar or vector? Yes, guess. So what is there? It is the scalar quantity. That means which product we have to take? We have to take the dot product. Okay, please remember that here. Now, so this is the general expression of the potential energy of the dipole. Which product? Dot product. Okay, good. Now what we are going to do? We are going to see some cases of the potential energy. In the exam it will come directly. Okay, so see here please, first one. Cases of different orientations of electric dipole in a uniform electric field. But before that, we should know the formula. What is the formula? U equal to minus Pe cos theta. Okay. Now here, theta how much? When the theta is 90 degree, then what will happen that here? This U value will come how much here? 0. And this is called what? See please. In this orientation, the dipole is in which position? Reference position. Because here, potential energy is 0. Okay. Next one, students, see please. When the theta equal to 0 degree, then what will happen that? See please. Then we can write here U equal to minus Pe, because cos 0 is 1. And here this potential energy is minimum. So when the dipole is in uniform electric field, force how much? 0. Potential energy minimum. So here equilibrium situation will be there. And this situation is called which equilibrium? This is called the stable equilibrium. Kindly remember that. Next one we can see, students, see here please. When theta equal to 180 degrees, so what will happen there? Cos 180 minus 1. So this U will come here plus EE. Okay. And here this U is maximum, force 0, potential energy maximum. So in this orientation, the dipole is in which equilibrium? The dipole is in unstable equilibrium. Okay, students. So now we have just reached to the end of the video. Just kindly comment, share and subscribe to my channel and keep watching my channel ASD Physics classes. Thank you so much, students.